have that the following diagram shows a semicircle. Okay, that's interesting. It's a semicircle with center O and diameter PQ. A rectangle OABC is also shown, such that AB is 8 and OA is 5. So let's first make sure that everything is written down. AB is indeed written down for 8 and OA is indeed written down for 5. It's important to notice that this is in fact a semicircle. So all we really need is to find the length of the arc BQ. So you guys, right off the bat, whenever you're facing circles at the AISL level, the sort of thing they can ask you to find is either length of arc, which is in your formula booklet, length of an arc, or area of a sector. These are the only two main things you really have to sort of like worry about, and there's not much to it. You might have to get creative with how to find some of the variables, but as long as you understand that these are the things that they can throw at you, then you should feel a little bit better. So in this case, we're going for length of an arc, so let's go ahead and write down the equation over here. So following the formula booklet, length, L for length of an arc, is going to be theta, which is going to be the angle, okay, facing my arc, divided by 360 times 2 pi r. So notice, technically from here you have three variables. You have L for length, you have theta for angle, and you have r for radius. Okay, now because you need to find the length of arc BQ, that means that I can leave length by itself, and I need to find the angle, and I need to find r. So once we take this approach of, okay, identifying the type of exercise, which is a circle problem, seeing that we have the formula for length of an arc and writing it down, and then really having very clear which variables we need and which ones we don't. And in this case, we need the variables in red, which is the theta and the r, which will end up giving me the length of our arc L, ¿cierto? I mean, length of the arc BQ with L. Once we establish that, now it's easier to have clear what we need to get first, ¿cierto? And so, if we're talking about the length of the arc BQ, let's go ahead and sort of like draw that, and I will be drawing that in blue, see? So if I go ahead and draw that in blue, the length of the arc, ¿vale? Let's leave very clear that when we're talking about an arc, okay, so in this case, arc, ¿vale? An arc is going to be like, or actually, let's do both, see? So if you have a circle like this, and let's say that this is your center O, see? And then here you go with R, here you go with R. If we're talking about length of an arc, this, for example, could be length of arc. And when we're talking about area of a sector, we're talking about this area here. So that is length of an arc, and this area is area of sector, okay? So just for us to have very, very clear the kind of thing that can come at us, in this case, we're going for length of an arc. And so in this case, because we're talking about length of arc BQ, that means we're talking about this arc right here, from B all the way over to Q. So this, ladies and gentlemen, is the length of the arc that we're trying to find. Now, the other thing that can really, really help us with this exercise is understanding that when you're trying to find the length of an arc, you need R, ¿cierto? And much like the example that I drew here for length of an arc, I first drew the origin. I first drew the origin right there, ¿cierto? O for origin, okay. This is the origin, lul. And so you first start from your origin, you see the length of your radius, and these two lines, as you can see, these two lines are exactly what help you define which arc you're going for, ¿cierto? So these two lines help you identify that I'm going for this arc here. And so here, working a little bit backwards, this arc in blue means that my two lines are from Q to O, because again, always to your origin, ¿cierto? Always to your origin, and from B to O. And so, the moment you do that, this exercise becomes a lot easier. Why does it become a lot easier? Because you just drew from point O, which is the center or the origin, over to the edge of the circle Q. So that means if I'm going from the center of my circle with O over to the edge of my circle in Q, and I know this is the edge, by the way, because it's part of the arc, ¿cierto? It's part of the semicircle because it's part of the arc that you're trying to find. If it goes from O to Q, that means that this right here is a radius. And from O to B is also a radius. They're the same value, ¿cierto? If this one's 3, that one's 3, they're both radius. ¿Vale? And so, oh wow, look at that. How convenient. OB is part of rectangle OABC. So that means that right here, kapow, you end up with Pythagorean theorem. So let's recall that with Pythagorean theorem, which usually looks like this, you have 90 degrees here, you have A, you have B, and you have C on the long side. Remember that C is part of the hypotenuse, it's part of the long side, it's the side that is to the opposite of 90 degrees. The Pythagorean theorem tells you that with a 90 degree triangle, you have A squared plus B squared equals C squared. See? So in this context, your C squared would be R because R is to the other side of the 90 degree. It's part of the long side, it's the hypotenuse, it's the slanted side, all that stuff. And so in this context, you can immediately say that 8 squared plus 5 squared has to be R squared. And so 64 plus 25 has to be R squared. So R squared has to equal, I think that's, how much is that? It's 89, I think. See, so 8, yes, 89. And so R is going to be the square root of 89, ¿cierto? And so immediately we can already say that, okay, this value here has to be R equals 80, square root, sorry, of 89. And so on one hand, I already got this radius, ¿cierto? And the next variable we need to find in order to plug in is this angle, ¿cierto? Now this angle, given the context, is the angle measured in degrees, ¿cierto? And so following this diagram that I put earlier, I didn't draw it in, I'll draw it in now. This angle that is formed by the two lines is what we're going to call theta. Okay, this angle formed by the two lines is what we call theta. So in this context, theta is going to be whatever is formed by these two lines, these two radius, or radii, or however you say it. And so this is actually the angle that you're going for, ¿cierto? So, oh, okay. So how do we go from there? What do we do now? And the main thing that should be coming to your mind at this moment, ¿cierto? Or once you establish or you recognize that we're talking about a rectangle, much how it says over here, the answer key, just so that you believe me. B-O-Q. Alright, so now we need to find this whole angle that's in red. See? Now notice, on the one hand, this whole angle that's in red, we can quickly establish, ¿cierto? Because it's next to a rectangle, that there's a 90 degrees right here. See? So I know that part of my angle in red is going to be 90 degrees. See? Now it's going to be 90 degrees plus, ¿cierto? Plus this angle there, ¿cierto? And this angle here is like the hard part of this problem. See? We're going to call this angle here x degrees. Okay? So how the heck do you find x degrees? The thing is, the moment you find x degrees, you can do x degrees plus the 90, that gives you theta. And that means you can plug in for the theta, you already can plug in for r, bada bing bada boom, you can solve. See? So how the heck do you get x degrees? Well, let's go ahead and draw our information. See? A lot of times it's good to sort of draw what you have to see what you're dealing with, this or that, etc. See? And so what you're dealing with right now is that part of the 90 degrees is point A, ¿cierto? And then when you go over this like height part or whatever, you have B, and over here you have O, okay? You know that from AB is 8, AO is 5, and BO is R, which we just found the square root of 89. And where is angle X? Angle X, as you can see, is between B, O, and A. So between B, O, and A, you have angle X, okay? So how do you find angle X from here? Of course, because you're trying to find angles and you're dealing with triangles, this is a trigonometry problem. That it? Trigonometry problem. Now, I know there's a lot of different methods and techniques for trigonometry. I know that you can use SOHCAHTOA, this or that, etc. And what I like to suggest, okay, what I like to suggest is that you use the same method always. And so the method that I always suggest for trigonometry problems is first, try with sine rule for the AISL level. See, try with sine rule. And then if it doesn't work, go to cosine rule, okay? Now I have other videos explaining sine rule and cosine rule a lot in depth, but the quick sort of 101 is that for sine rule, okay, if I go over here with sine rule and cosine rule, you notice that you have big letters and small letters. So you have big letters and small letters all over the place, and notice how the big letters are always part of a sine or of a cosine, and that's because whatever you put inside a sine or cosine has to be an angle. So what am I telling you here? That big means we're talking about an angle, while small means we're talking about a side. And how do you associate these angles to the sides? ¿Cierto? If you have big C, how do you know what's little c? Well, take a look at this triangle here. If this is angle A, then little a has to be over here. If this is angle B, then little b has to be over there. And if this is angle C, then little c has to be over there. See, that's like the basic 101 of sine rule. And so in this context, you're trying to find angle x, ¿cierto? So my method for trigonometry is first trying sine rule. If that doesn't work, cosine rule will work. See, there is no third option. At least for AISL, this is a pretty good strategy. ¿Vale? So having in mind the sine rule, let's think about what is related to this angle x. So remember, you gotta like see what's on the other side. See, so angle A has related to it whatever side is sort of like facing it. See? So in this case, angle X has the 8 facing it. So that means that following this formula here, ¿cierto? I can go ahead and say that 8, which is side 8, ¿cierto? Divided by sine of X has to equal, and now I need to consider another pair, ¿cierto? So for example, this angle here, I do not know it, so why would I pair it with a 5 if I do not know it? It's a lot of extra work. Instead, you know this angle here. You know that this angle is 90, and it's related to the square root 89. So that means I can put square root 89 divided by sine of 90. And from here, because you need to get x alone, you can just go ahead and what I like to do, the first step is always cross multiply. So that means you end up with 8 times sine 90 equals sine x times square root 89. Now you want to get x alone, ¿cierto? So you can divide both sides by square root 89, divide by square root 89. This goes away with this. You end up with sine x equals 8 times sine 90 divided by square root 89. Now, you want to get x alone, ¿cierto? And x is inside of sine. And so what do you do here? Well, just to explain it in very, very simple terms, if you have 2x equals 4, what do you do? 2 times x equals 4, you divide by 2. You divide by 2 because division is the inverse operation of multiplication. So you end up with x equals 2. Now the thing is, what is the inverse operation of sine? The inverse operation of sine is sine inverse. Look at that. So if you put sine inverse over to both ends, what happens is that this goes away with this, and you end up with x degrees being equal to sine inverse of this whole thing. 8 times sine 90 divided by square root 89. See? So you put all of that into your calculator and trust the process and it'll work. See? So make sure that you can go to mode and have it in degrees. If it's in radian, you're going to get the wrong answer. So we're going to go ahead and do sine inverse, put a parentheses with alpha y equals, then press the first one, 8 times sine 90 divided by square root of 89. Close everything, see what happens. You end up with 57.99. So x degrees has to be 57.99. If you think about it in terms of significant figures, you count 1, 2, 3, round it up or keep it the same, you round it up. So you can actually leave x degrees as 58. Okay, x degrees is 58. And we said that angle theta is going to be 90 degrees plus x degrees. And you just found that x degrees is 58. So that means that theta, ¿cierto?, is going to be 90 plus 58. 90 plus 58. Angle theta ends up being 148. So now, ladies and gentlemen, we can finally plug in with everything we have found. You found your radius, you found your theta being equal to 148, and now you can plug in to find the length of arc BQ. And if you go ahead and do that, for example, here you end up with my angle we said was 148, and my radius we said was square root of 89. So you put all of this into your calculator, trust the process, trust the formula, and you end up with, let's find out, times 2 times pi times square roots of 89. So you put all of that into your calculator and end up with 24.368. So 24.368. We are talking about a length, so we can leave it as, they actually don't give you the units. You can just say this amount, see, 24.368 units. If you think in terms of significant figures, you say 1, 2, 3, round it up or keep it the same, you round it up. So you can actually leave this as 24.4. All right, and if we go to the answer over here, there is the 24.4. See? So, ladies and gentlemen, notice how here we find the radius. Here there's a couple different methods, but as you can see, they get into arctan and this and that. They use SOHCAHTOA, and personally, although it works, I always found it a little more confusing. And I like to show you or teach you methods that might take a little bit longer but always work. See, so in this case, the method that takes a little bit longer but always works for trigonometry problems is this approach. First try the sine rule, then go to cosine rule. Forget about everything else. This works for AISL. For other levels, not so much. That being said, that is number 11, and I hope it helped.